Okay, the topic for today is crashing. Crashing, which is also termed as time cost trade-off. So we are going to start a practical on crashing, whereby we will be reducing the time as well as cost of the project. Now this is one of the most important techniques in management, whereby you reduce the time as well as cost of the project. Both these elements are very essential, and crashing becomes very significant because it not only decreases the time but also decreases the cost of the project. So remember, the term crashing is used for decreasing the time as well as cost of the project. Now take out practical question number 17, and we are going to start with the practical on crashing by taking this example. First of all, tell me what are the nodes that are used in this project, because in crashing, first of all we will have to construct the diagram. And how the diagram will be constructed? Please tell me what are the nodes?
1
to 2. So the first node is comprising of these events 1 to 2. Now remember, a diagram will have to be constructed in every question of crashing in PERT CPM. Right? It is an indispensable part of PERT CPM. So 1 will be connected with 2, and this is activity A. So in circles, numbers are always written, while the alphabets which are denoting activities are placed in the midst of these two numbers. Next activity 2 to 3. So 2 will be connected to event 3, that will be activity B. Next 2 to 4. So 2 will be connected with 4. Now that will be activity C. Next
2 to 5.
2 to 5. Now 2 will be connected with 5. That will be activity B. Next
3 to 4.
3 to 4. So 3 will be connected with 4, and this is activity E. So this is activity E. Next
4 to 6.
4 to 6. So now 4 will be connected with 6, and this is activity F. Next
5 to 6.
5 to 6. This 5 will be connected with event number 6, and this will be activity G. Right? Anything else?
No, sir.
Okay. So we have to construct the network diagram initially, and how this network diagram will be drawn. This will be drawn with the help of the nodes or activities which are given to us. All these points will be connected to each other, and the lines, they have to be straight. Right? They can move upward or downward, but circular or zigzag lines are not allowed. Now please tell me the normal time of activity A. What is the normal time?
3 weeks.
That is 3 weeks. So normal time is written outside, and there must be one more concept that is called as crash time. Now crash time is the shortest time. What is the crash time of activity A? 2. So crash time will be written in brackets, and normal time will be written outside the brackets. Next, for activity B, what is the normal time?
3.
3. And crash time?
Also 3.
That is also 3. Next, for activity C, normal time?
5.
5. And the crash time?
3.
3. Remember, crash time is the shortest time to do an activity. Now, normal time will always be written outside, and crash time inside the bracket. For activity D, what is the normal time? 4 weeks. And the crash time?
It is also 4.
Also 4. Next, for activity E, normal time. What is the normal time of activity E? 4
weeks.
And the crash time?
1 week.
That is 1. For activity F, what is the normal time for activity F? 3. And crash time?
2.
That is 2. For activity G,
3.
that is 3 normal time, and crash time?
1.
That is 1. So first we have to draw the network diagram. That is the base of PERT CPM crashing. Next, we have to place the normal time outside the bracket and crash time inside the bracket. Next, take down a formula to calculate the cost of reduction. The next step is to calculate the cost of reduction. Now remember, cost of reduction is also called as cost slope. Cost of reduction, the another name of cost of reduction is cost slope. And how this cost of reduction is calculated? Cost of reduction is calculated by this formula, which is crash cost minus normal cost whole divided by normal time minus crash time. Right? So cost of reduction is calculated by using this formula, which is crash cost minus normal cost whole divided by normal time minus crash time. Now please tell me, what is the crash cost of activity A?
300.
Crash cost is 300. What is the normal cost of activity A?
450.
That is 450. Crash cost. The crash cost is 450. You just told me the vice versa. The crash cost of activity A, that is 450, right? And the normal cost of activity A is 300, right? So we are going to place these values in our formula to calculate the cost of reduction for activity A, that is 450 rupees minus normal cost. Normal cost is 300. Now tell me, what is the normal time? Normal time of activity A?
3.
That is 3. And crash time of activity A?
2.
That is 2. So how we are going to place it in this formula? The normal time will be equal to 3 and the crash time will be equal to 2. Now we are going to solve it. 450 minus 300. On the numerator side we will have 150 and 3 minus 2 will give us 1. So 150 divided by 1 will give us the cost of reduction of activity A as 150. Right? So we start placing all these values in our table. The cost of reduction for activity A is 150 rupees. Next, we are going to calculate the cost of reduction of activity B by using this same formula. Then cost of reduction of activity C, D, E, F and finally G. So we have to calculate the cost of reduction of each activity. Now tell me, what is the crash cost of activity B?
75.
Crash cost
75.
75. And what is the normal cost?
75.
That is again 75. Now the normal time of activity B? 3. And crash time?
3 weeks.
That is also 3. Now when we will place all these values in our formula, we will get the cost of reduction as simply equal to 0. Right? So for activity B, the cost of reduction will be equal to 0. Now can you calculate the cost of reduction of C, D, E, F, G by applying the same formula? Right? Please try to calculate it. Then we will check down all the values.
C is 100.
Okay, for C, what is the crash cost for activity C?
Crash cost is 300.
That is 300. Normal cost?
200.
200. Normal time?
4.
4 given in the question.
C 5.
For activity C, the normal time is 5. And crash time? What is the crash time?
3.
That is 3. Okay. Now when we apply this formula, the value will be 300 minus 200 whole divided by 5 minus 3. Now that will give us 100 divided by 2 will be equal to 50. So the cost of reduction of activity C will be equal to 50. Now try to calculate the cost of reduction of activity D. What is the crash cost of activity D?
120.
120. The normal cost?
120.
120. Normal time?
4 hours.
4 weeks. And crash time?
4 weeks.
That is also 4 weeks.
0.
So 120 minus 120 upon 4 minus 4 will again turn out to be 0. What is the crash cost for activity E given in the question?
190.
190 rupees.
100.
This is 100. Normal time
4 weeks.
4 and crash time
1 week.
that is 1. Now when we apply this formula,
30.
190 minus 100 whole divided by 4 minus 1. So 190 minus 100 will be equal to 90 and 4 minus 1 will be equal to 3. So 90 by 3. The cost of reduction of activity E will be equal to 30. For activity F, what is the crash cost?
130.
130.
90.
For activity F, normal cost is
90.
only rupees 90. Normal time
3 hours.
3 weeks and crash time is
2 weeks.
2 weeks. So 130 minus 90.
40.
Now 130 minus 90 will be equal to 40 and on the denominator side 3 minus 2. So 130 minus 90 will be equal to 40. 3 minus 2 will be equal to 1. 40 divided by 1 will be equal to 40. Now the last one. Activity G. What is the crash cost?
110.
110. What is the normal cost?
60.
60. Normal time
3 weeks.
3 weeks and crash time
1 week.
that is 1. So now by placing all these values in our formula, 110 minus 60, crash cost minus normal cost, whole divided by normal time minus crash time. So 50 divided by 2 will be equal to 25. So this is how we are going to calculate the cost of reduction of each activity. Remember the initial steps. First, we had constructed the network diagram, right, by using all the nodes and activities given to us in the illustration. Second step is to calculate the cost of reduction, and cost of reduction will be calculated by this formula which says crash cost minus normal cost whole divided by normal time minus crash time. And the another name for cost of reduction is cost slope, right? Next step. Now we are going to construct a table for various possible paths. So we are going to construct this table for various possible paths. We are going to find their normal time, which can be simply denoted by NT, and the shortest time. Now the shortest time or the crash time, this can be denoted by ST. ST stands for shortest time, or in simple words, crash time. So we are going to construct this table to find out the various possible paths. Various possible paths indicate the paths from which we can reach from the first point to the last point, to the terminal point. Now one path could be 1, 2, 3, 4 and 6. Right? This is one path. 1, 2, 3, 4, 6. Another is 1, 2, 4, 6. And another one could be 1, 2, 5 and 6. So various possible paths indicates the paths from which we can reach the terminal point while we are starting from the first event. So as I said, the first path could be 1, 2, 3, 4, 6. Activity based, it can be written as 1 to 2 will be A, 2 to 3 will be B, 3 to 4 can be written as C, and 4 to 6 will be written as F. So one path is activity A, B, E and F. Another path will be A, C and F. So that will be the next path, ACF, and finally the last one will be A, B and G. So in this practical, we have 3 different paths which will help us to reach the terminal point when we will start from point number 1. So various paths indicate the various paths which are available to us while reaching the last point when we are starting from the first point. Now the normal time. Now as far as the first path is concerned, ABEF, we have to add all the values of the normal time to get the total normal time. Now for ABEF, the normal time of A is 3, normal time of B is also 3, normal time for E is 4, and the normal time of F is 3. So 3 plus 3, 6 plus 4, 10, plus 3 will be equal to 13. Right? Adding all these values of normal time, we will get the total normal time of ABEF as 13. And the shortest time, for shortest time you have to add up all the values which are inside the brackets which were representing crash time. So 2 plus 3, 5 plus 1, 6 plus 2 will be equal to 8. Now ACF, A, C and F. So the normal time of A is 3, C is 5 and F is 3. So 3 plus 5, 8 plus 3 will be equal to 11. Next, the shortest time would be 2 plus 3, 5 plus 2. That will be equal to 7. And finally, A, D and G. For A it is 3 plus 4, 7 plus 3. That will be equal to 10. And the shortest time 2 plus 4, 6 plus 1 will be equal to 7. So we have to take down all the normal time values for all the various possible paths as well as the shortest time. So please note down the values up till here, then we will proceed further with this concept of crashing. Crashing, which is also called as time cost trade-off. Now we are going to construct the next table. Right? The next table, the heading of it is cost sheet. After the first one, that was diagram, cost of reduction values, various possible paths table. Now we are going to construct another table which will be called as cost sheet. The first column will be number of, in this question the duration is in weeks or days? Weeks. So the first column will be number of weeks. That will be the first one, number of weeks. Next is the segment for direct costs. Now remember, direct costs are of 2 types only. One is total normal cost and another is crashing cost. All the other costs are termed as indirect costs. Now there could be many indirect costs. The indirect costs, they are also termed as penalty costs, overhead costs. But you don't need to remember the name of all the indirect costs. What do you need to remember? That normal cost and crashing cost, they are a type of, they are the different types of direct costs, while all the other costs are indirect costs. So indirect cost, in the last line, it is clearly given. The indirect costs of this project are rupees 100 per week, right? So indirect costs, they will be at the rate of rupees 100 per week, and you will have to total them up to achieve the total costs. So this is going to be the format of the cost sheet which we will be constructing. First column is for number of weeks. If the question is in days, then it would be number of days. Next segment is of direct costs. Direct costs are bifurcated, or direct costs are classified into 2. One is normal cost, another is crashing cost. All the other costs are indirect costs. Now we will have to find out the interval of crashing, and for that we have to select the highest values. Remember, the highest value in this column is 13 and the highest value in this column is 8. So we are going to crash the project from 13 till 8. Remember that crashing interval is derived by taking the highest values of both these columns. The highest value in this column is 13 and the highest value in this column is 8. So this will give us the interval of crashing. That means we are going to find out the total cost at each interval. Now what will be our final answer? The total cost, they will decrease. They will decrease up to a certain extent. Then you will achieve a minimum cost. And after that the costs will again increase. The point where the total costs are minimum will be our final solution. So we are going to find out that interval where our total costs will be minimum. How will we get that? First of all, is this duration clear? Attend to it. This was achieved by taking the highest values from both these columns, right? Now just tell me, what is the total of the column which is giving us normal cost? To achieve the total normal cost, you have to total all the values in this normal cost column. So please add up all the values and tell me what is the final answer. What is the value of the total normal cost? Please add up all the values.
945.
945. Now remember, these normal costs, they are going to remain same throughout the duration of the project, irrespective of the fact whether the project is completed in 13 weeks or 10 weeks or 8 weeks. These costs are going to remain same, right? For that you had just to total up all the values of the normal cost, and adding up all those values are giving us the total normal cost as 945. Now see, indirect costs were rupees 100 per week. If the indirect cost of 1 week is rupees 100, then the indirect cost of 13 weeks,
1300.
that will be equal to 1300. The indirect cost of 12 weeks will be 1200. The indirect cost of 11 will be equal to 1100. For 10 will be equal to 1000. Indirect cost for 9 will be equal to 900. And finally for the last one, for 8 weeks will be equal to 800. So what do? We need to multiply the value of the indirect cost with the respective duration. For 13 it will be 1300. For 12 it will be 1200, and so on. So is this clear up till here? Please take down the values up till here, then we will proceed further. Okay, so we start. Now remember, the first entry in crashing cost is always dash. In each and every question, the first entry would always be dash, because we have not reduced any activity. So when we have not selected any activity for reduction, we don't need to pay any cost. So remember this golden principle, that the first entry in every problem of crashing will always be nil or dash. 945 plus dash will be equal to 945. Now 945 plus 1300. Please add up both these values. 945 plus 1300 will give you 2245. Now this is giving us a figure that if a project is completed in 13 weeks, the total cost of completing the project will be equal to rupees 2245. Now what will we do? We will try to decrease the duration of the project, simultaneously decreasing the cost of the project. So this is such an important aspect, whereby you reduce the time as well as cost of the project. And how will we do that? Now you will have to take down the working notes for crashing. Now for working notes of crashing, we are going to select the first path, and remember, how will that be selected? In this column, you have to see which path is having the highest value as far as normal time is concerned. So you have to consider normal time, and the highest value of normal time is 13, right? 13 corresponding to path A, B, E, F. So in every question of crashing, remember this rule that we have to select that path which has got the highest value. That is, indeed the critical path. That path is called as the critical path which has got the highest duration, and now you have to select those paths only which have got the highest duration. So the highest duration is A, B, E, F. Now from these 4 activities only, you have to select that activity which has got the least cost, right? So the cost of reducing A is 150 rupees derived by the formula. B, remember activity B cannot be considered for crashing. Similarly, activity D cannot be considered for crashing. Why? The reason is all those activities in which the normal time and the crash time are equal. In activity B, the normal and crash time are equal. Similarly for D, normal time and crash time, they are exactly same. So for all those activities where the normal time and crash time are same, they cannot be considered for crashing. So we are not going to consider activity B because the normal time and crash time is exactly same. So leave aside B. The cost of reducing A is 150. The cost of reducing E is 30. And the cost of reducing F is 40 rupees. So out of all these activities, what is the lowest cost of reducing? That is activity E, right? So activity E will be selected. I give you a recap. We have to select that path which has got the highest value. That was A, B, E, F. Now from this path, we have to select that activity which has got the least cost of reduction. That is activity E. So the cost of reducing activity E is rupees 30. Now remember, you will have to make entries at 4 places simultaneously. Which are those 4 places? Number 1, you will have to, make an entry in crashing. And the treatment will be cumulative. We have to do the cumulative cost and then we have to place in our cost sheet. So the first entry is always done in working notes of crashing, where we have selected this particular activity E and derived the cost of reduction as 30 rupees. Next, entry number 2. It is always done in the cost sheet. So 30 rupees is being placed in the cost sheet. 945 plus 30 is giving us the cost of reduction as 975. And 975 plus 1200. So 975 plus 200, 1200 will give us 2175. So now see, we are reducing the time and simultaneously the costs are also decreased, right? So we are decreasing the time as well as the cost of the project. So as I have told you, the entries have to be done at 4 places. Number 1, working notes in crashing. Number 2, cost sheet. Number 3, in this diagram, which activity is selected? Activity E. So activity E is now reduced from 4 to 3, right? That is what you have paid for. You have paid, the contractor 30 rupees to reduce this activity E. So now this activity E will be reduced from 4 to 3, and simultaneously when activity E is reduced, it has to be reduced in various possible paths table. So all those paths having activity E, remember all those paths having activity E will be reduced simultaneously, but as we see, activity E is lying only in the first path. So it will be reduced from 13 to 12, right? You can always tally it up. A, B, E, F. Earlier it was taking 3 plus 3, 6 plus 4, 10, and now 3, 13. So it was taking 13 weeks to be completed. But when you have reduced the activity E, so now the revised duration will be 3 plus 3, 6 plus 3, 9 plus 3, 12. So you have to show that value in your various possible paths table. So you have to make entries at 4 places simultaneously. First, in the working notes of crashing. Second, cost sheet. Third, in the diagram. And fourth, in the various possible paths table. Now we proceed further with the next step in crashing. Again, this is the highest value, right? The highest value is 12. So we have to select this path once again, that is A, B, E, F. Now, as I told you, activity B cannot be selected. So the cost of reducing A is 150, the cost of reduction of E is 30, and for F it is 40. So again, activity E will be selected because the cost of reduction of activity E is 30 rupees, and remember, it has to be done cumulative. The word cumulative means that the current cost will be added to the previous cost to give us the total cost. So the total cost will come out to be 60. Now 945 plus 60 will be equal to 1005, and 1005 plus 1100 will be equal to 2105. So we have to make entries at 4 places. Number 1, crashing. Number 2, cost sheet. Number 3, in a diagram. So which activity we have selected? We selected activity E. So now E will be reduced from 3 to 2. Right? The duration will come down to 2, and simultaneously the entry has to be done in various possible paths table. All those paths carrying activity E will be reduced, but it does not lie in second or third path. So we are going to make adjustment in only the first path. So 12 will be now reduced to 11. Is this clear? Up till here? Okay. Next, crashing number 3. Third crashing. Now see, both these paths are having same values as far as normal times are concerned. So now we have to select both these paths. Path A, B, E and F, and then A, C and F. Now remember, we cannot select activity B, but we have to select one activity from each path. Now one activity can be selected from each path by taking either a different activity from each path or taking an activity as common. So activity A is common in both these paths, but it is having a cost of rupees 150. If you observe over here, activity F is also common, right? And the cost of reducing F is only 40 rupees. So what do? We will select activity F. Why F? Because the activity F's cost is quite less than the cost of activity A. So activity F is common. Now the biggest advantage of taking an activity as common is that both the paths will be reduced simultaneously, and you will have to pay cost only once. So the cost of reducing F is rupees 40. And the previous total was rupees 60. So now the grand total will be equal to rupees 100. So first entry is done in the working notes. Next, second will be done in cost sheet. 945 plus 100 will be equal to 1045. Now 1045 plus 1000 will give us 2045. So now entries have to be done at 4 places. Number 1, working notes. Number 2, cost sheet. Number 3, in the diagram. Which activity we have selected?
F.
We just selected activity F. So now activity F will be reduced from 3 till 2. And now activity F is existing in both the first as well as the second part. So now the revised duration will be
10.
For F it will be equal to 10. Again ACF will be equal to 10. Since F does not lie in the third path, so we are not going to make any adjustment in the third path. So kindly take down the values up till here, then we will proceed further. Okay, so is it clear up till here? Next, we just need to do 2 more crashing, then we are through with this important practical of crashing. So have you taken down the values up till here?
Yes, sir.
Okay. So now crashing number 4th. We are on this 4th crashing. Now if you observe carefully, all these values are absolutely same. All these paths are having same normal time. So now we have to select all these 3 paths. Path A, B, E, F. Then ACF and ADG. Now again, observing this activity F, we come to the conclusion that the normal time as well as the crash time are exactly same. So now on we cannot consider activity F further for crashing, because all those activities where the normal time and crash time are exactly same, they cannot be considered for crashing. So we will not consider activity F. Now if F cannot be considered, what could be the other options? Either we can take activity A as common. Now if we take activity A as common, the cost of reduction of A will be equal to 150 rupees. Right? Previous total. What was the previous total? That was 100 rupees. Adding the previous total will give us the grand total as 250. So one option is that we can take activity A as common in all these 3 paths. The other option could be taking a different activity from each path by taking the lowest valued activity. So if you see the first path, we cannot take activity F, but we can still select E because the normal time is 2 and the crash time is 1. So if we select activity E from the first path, right, that will give us the cost of reduction as 30. Now in ACF, activity C is also there because the normal time is 5 and the crash time is 3. So if we select activity C from this path, the cost of reduction will be 50 rupees. And in the last, we cannot select activity D, but we still have the option to select activity G, and the cost of reduction of activity G is 25. So now if we add all these 3 values, 30 plus 15, 80 plus 25 will give us 105, and the previous total was 100. So the cumulative grand total is 205, which is quite less than the cost of activity A, which was common in all these 3 paths. But still, this option will be rejected because the cost of taking a different activity from each path is quite less. That is equal to 205. So we will take 205 as the total cost. Now 945 plus 205, that will be 1150, and 1150 plus 900 will be equal to 2050. Now if you look at this column, the total costs, they kept on decreasing. They were decreasing till we reached point number 9, where the costs had started increasing. So we have got our solution, but still we will complete this process of crashing, then we will come to the conclusion. So we have done entry at the first place, that is the working notes of crashing. We made an entry in the cost sheet segment. Now the third, which activities we selected? We selected E, C and G. So E will be reduced by 1, which means that we cannot take activity E further. Activity C will be reduced, that will be equal to 4, and activity G will also be reduced, it will be equal to 2, and simultaneously ECG, all these activities and all the respective paths will also be reduced by 1. The resultant duration would be 9 for this, 9 for this, and 9 for the last one. So entries are done at all those 4 places. Now we come to the last crashing of today's lecture. That is the crashing of all these 3 paths. Right? Again, all these durations are equal. So in the next crashing, the last crashing, we will have to select all these 3 paths: A, B, E, F, then ACF, and ADG. Now just see, we cannot select activity B. Activity E is also gone because the normal time as well as the crash time of activity E is same. Activity F is also not there. So we cannot select either activity B or E or F. So we are left with only activity A. Now when we are taking activity A in the first path, then it is better to take activity A as common in all the paths because we don't have any other option. We are not left with any other activity because B, E and F, all these three activities, B is not there, E is not there, and F, normal time and crash time is absolutely same. So it is mandatory to take activity A, and when we are taking activity A as A in the first path, then we will have to take activity A as common in all the paths. So the value will be equal to
150
the cost of reduction for A was 150 plus the earlier total,
200.
it was 205, leading to the grand total of 355. Now 355, we'll place it in our cost sheet. 945 plus 355, that will be equal to 1300, and 1300 plus 800 will give us the total cost as 2100. Now remember this rule, as I told you earlier, the cost will continue to decrease till they reach a minimum point, and when they will start increasing, they will increase. They are not going to decrease again. So we made an entry over here in the working notes. Second entry is done in the cost sheet. Then third, we selected activity A. So activity A will be reduced, and now the revised duration will be equal to 2, and all those paths having activity A will also be reduced simultaneously. So A exists in all these three paths. It will be reduced to 8. This will also be reduced to 8, and finally the third path will also be reduced to 8. Now we come to an end of this whole process of crashing, and from looking at this cost sheet, we can easily determine the minimum total cost is rupees 2045, which is lying in the 10th week. So now take down the conclusion, the whole summary part. Please take down the conclusion. Since the total cost is minimum, in the 10th week, that is rupees 2045, therefore the project should be crashed till or the project should be reduced. So the project should be crashed till 10th week. So the project should be crashed till 10th week. That is, the suggestion which we have just given to the management, that since the total cost is minimum in the 10th week, therefore the project will be reduced up till 10th week only. Is it clear?
Yes.
Okay.